Hello, everyone. Good morning, good afternoon, maybe good evening, depending on where you are connecting from. Uh, Thanks a lot for joining us today. We'll just do the introductions in the next slide. Let me start this in presentation mode. Again, thanks for watching our workshop. Thanks for connecting. Thanks Apidays for the opportunity to present this workshop as well. What we're going to present today is from the backend to the API, so end-to-end guaranteeing security, so open strategies with Sensedia. I would like to ask my friend Filipe to introduce himself.
Sure. Thanks everyone for joining us, and thank for Apidays about the opportunity. Well, I'm Filipe Torqueto. I'm lead software architect here in Sensedia.
And my name is Gibson Nascimento. I'm the head of solutions looking after the EMEA region. If you want to connect with us, please don't hesitate to either use the QR codes that you can see on your screen or send us direct message here during the chat. We will try to answer all the questions as much as we can. Otherwise, we can always catch up later. So for today, the agenda, as I just mentioned, we are going to talk about how you expose your backends, how you expose APIs from your backends with security. In our agenda, what we want to cover is microservices and APIs, security concerns for those two topics. What is the role of service mesh as well as the API gateway, how they help us to do that. Security specific for microservices and specific security concerns for APIs. And of course, we are going to show a demonstration of these two tools that we're mentioning, the service mesh and the API gateway, to guarantee the security when you're exposing APIs from your backend applications. And if I may start talking specifically about microservices and APIs, when it comes to security concerns, right? Microservices and APIs, depending on the way that you're exposing your APIs, you could expose public APIs or even private APIs, so internal APIs. They need to be exposed with security. It needs to be 100% sure that even if you're exposing internal APIs only, that you guarantee security to make sure that only the authorized users will be consuming APIs. So some of the main points to consider when designing your microservices and API strategy is the standardization of security, right? Depending on how the company is structured, for example, we know we've been talking a lot about DevOps, about DDDs, about the different concerns or the definition of different teams inside the corporation. Teams that are self-contained, that are multidisciplinary teams with people from different competences. And sometimes all of these teams, they are also autonomous enough to implement their microservices, implement their APIs, following the standards that they believe are the best ones. But as a concern, a security concern, sometimes giving all of this freedom also brings some concerns, right? Some considerations. And the standardization of the security is one, or maybe the biggest one. Making sure that the different teams understand the patterns, understand that the security implementation that they have to put in place before exposing an API, it's something very important. And it helps a lot in guaranteeing that the applications that you are exposing, they are protected in the way that they should be. Another concern, another pain point, and Filipe, please feel free to jump in anytime you need.
Yeah. Of course, about security itself, there are more concerns involved. Okay, so we are focusing the most part of the security concerns on the API perspective, on the integration perspective, in channel security and authentication and authorization. Of course, involving also rate limitings and injection protections. And more than standards, we need to guarantee that those standards are being followed. So also the focus here will be how we can use Sensedia tooling to help a company to establish those standards enterprise-wide using the platform, of course.
Yeah, thank you for that. So when it comes to the communication, securing the channels, making sure that you have protocols in place that guarantee the traffic of data. Filipe mentioned about authentication authorization processes as well. So having this well defined with the right level of authentication authorization in place. And also, this may not be considered security as per se, because we're talking about rate limiting, about protections. But in the end, when you design your APIs, you design your microservices with protection, you're also securing those, right? So if you are limiting, if you know the limitations of your backend and you're limiting the number of API calls that those applications can receive, you're also making sure that they are not going to break. So hence, you're guaranteeing security of your applications as well. Moving to the next slide here, Service Mesh and API Platform both have very well defined responsibilities. I know that today we're going to mainly focus on security, but I just wanted to bring the main benefits of adopting those two platforms. And when we talk about Service Mesh specifically, as we can see in this image here, Service Mesh remains in the let's say internal layer, guaranteeing the east and west traffic communication. So mainly communication between or among multiple microservices, guaranteeing security, the management of the traffic among all of these microservices, bringing observability, abstracting the complexities of the network, and of course, making sure that developers can work for business instead of infra, because we are abstracting all of the complexities of the non-functional requirements. So all of these benefits that I mentioned, they are responsibility of the Service Mesh platform. So by adopting a Service Mesh platform, you are making sure that you can define traffic, the different traffic controls, so you can plan canary releases. You understand end-to-end the chain of communication. So what instance of a microservice called the other one? So what is the instance responsible for that specific request? And you can also identify possible errors. If there is a huge delay in the network, you can understand exactly what is going on. So that's the observability. And of course, the abstraction of the network. So you remove all the complexities, all the implementation of the network by implementing Service Mesh. On the other side, the API platform, so it's guaranteeing that the communication towards the external world, that again, it's very important to highlight here that when we say external world, it could still be a private API that is, for instance, exposed to a different business unit of the same company, same enterprise, but still it's external to the context of that microservice or that application. But of course, we can also have external facing, public facing APIs. If you think about Uber, for example, about Amazon, Netflix, they do have different strategies. Could be protected strategy where they only expose APIs to partners, or a fully, that's the Amazon example, or like Netflix that has a private API, only their applications use their APIs, or Uber that has an open API for the strategy, fully open to the public. That's the goal of the API platform, to protect those APIs and guarantee that you are allowed to create products of your APIs, that you provide governance on top of your APIs. So you understand what is going on end to end, who is using, who is consuming, how they are consuming your APIs. You guarantee security, so you enable all the different security standards from the authentication authorization patterns to, like I mentioned before, rate limitings, different throttlings that you want to apply, or even the SQL, XML, all of these injections, you can guarantee security on top of that. And the channel as well. So we are going to show that shortly in the demo. So how you guarantee that the channel, the communication between your APIs and the end consumers are also secure. The API platform also enables a good developer experience. So of course, when an API is well-defined, well-designed, you guarantee that the developers consuming your APIs have a good experience with that. The management of the API consumers, so you understand how partners, how the third-party developers, or even internal developers are consuming and are using your APIs. And of course, from a compliance standpoint, you can audit, you can understand end-to-end. So when you are in a, for instance, PCI environment, credit card transactions, you have auditability to understand everything end-to-end if anything has happened with your APIs. Specifically about the microservices security, talking about service mesh now, some patterns, some considerations have to be taken into account while designing your microservice strategy. And service mesh does help, does support those specific concerns. They help addressing those concerns. So when we talk about zero trust network, so even though you may have a distributed cluster, you may think, I don't really need to secure the channel, for example, but on the other hand, you have a distributed environment. So how do you guarantee that the connection from cluster A to cluster B is really secure? So service mesh helps with that as well, securing the channels, internal. That's called the internal communication channels. Communication towards the ingress gateway MTLS, so guaranteeing the communication towards the external cluster, external to the cluster. Intra-service communication also with MTLS. And even though we are talking about internal APIs, internal communication, so microservices within the cluster, it is also possible to configure to enable authentication authorization, not only for the external communication, but also internal. So those are some of the features that the service mesh brings to guarantee security for microservices. The API platform, on the other hand, guarantees that the external communication, either to partners or even the communication towards the backend applications, they are fully secure using MTLS, for example. You guarantee the authentication using, for instance, all flows, authentication authorization. And I mentioned previously injections. So all sorts of injection protections, that's the responsibility of the API platform. And also DDoS attacks, so you can protect those by implementing different policies for the APIs. And Filipe, I will hand over to you. So now we're going to present a demo. We have an interesting use case here where we're going to show end-to-end how to secure APIs and microservices using Sensedia's platform.
Sure. So basically, setting the scene here, we have two different tools in the Sensedia perspective. We are using our service mesh in one hand, protecting the services and microservices. In the other hand, we are using the API platform to expose the APIs to partners and consumers in a secure way. So as the architecture is being shown here, and I will start with the API platform itself. So I do have three services here in my service mesh perspective: account service, payments, and customers. So just the account service have external service, which is the statement service. I want my statement, for example. So this API is publicly exposed throughout my Ingress gateway here. And all those services are being managed by our service mesh. And of course, this API is configured throughout our API gateway that I'm going to show you guys. Let me just share my screen, Gibson.
Sure, I'll stop sharing mine. Yeah, over to you.
Okay. Are you guys able to see my screen, Gibson? Okay.
Yes.
Okay, so this is the service mesh product, okay, just to set the architecture itself. So as I said, we do have 3 services running, okay, account service, payments, and customers. And like I said, just one service have a public API exposed, which is the account service. And behind the scenes, I'm generating traffic to show you guys the flow online, what is happening throughout the cluster. So basically, my account service is grabbing information from payments and grabbing information from my customer, and to give me the statement at the end of the day, and to give me the response from my customer. Okay, so this is the service mesh perspective, and this is part of the service mesh product. I'm going to show in more deep details what is going on behind the scenes. But first, let's move forward to our API platform. So this is our gateway, API gateway. Okay, this is the front end for it. And this is my bank account API exposed, which is the basic path is -bank-v1. And I does have 3 environments, 3 different environments, which this API is deployed, 3 virtual environments. The most important that I'm going to use in the demo is this one, openinnovation.apiplatform.sensedia.com, because this environment here is configured with the MTLS encryption already that I'm going to show you guys. And those are the resources, the operations itself. And moving forward to security perspectives. Okay, so this is the API itself. No big deal here. Let's move forward to the interesting part. So part of the security perspective here in our API gateway. Okay, so it does have security capabilities out of the box, so no coding involved. This drag and drop box here will create a client credential, in this case, an OAuth validation with the client credentials flow, okay? But, well, as you guys can see, I can choose whatever flow I want. In this case, I'm just using client credentials to keep things simple. We do have a SQL thread protection, and at this case, I'm protecting the entire call, body, header, square params, cookies, so on and so forth. XSS thread protection also. We do have ready-made rejects to catch some already knowing patterns, but this is configurable, whatever rejects you guys can configure here in whatever location also. This header here is just because my load balancer needs it. There's no security involved. This payload sizing is just to limit. I just put a huge payload size just to show the possibility what we can do, dragging and dropping the API gateway. Of course, the payload size here is just to limit how far a payload can go in this request. And in the logging perspective, we also have 2 different capabilities, which I can encrypt the content of the log, and I can encrypt even the URL path and query params of the log itself, because we know we do have in Brazil LGPD, which is the law protection, and in Europe, for example, we do have GDPR concerns. And of course, we do have the disclaimer here to warn when you put the log, you need to be warned that the data will be exposed, and if this data is critical, please encrypt the log. So those are some of the security capabilities that our gateway comes. And again, out of the box, no coding involved, it's just drag and drop. We do have others like rate limiting, spike arrest, for example, and again, in drag and drop fashion here. I will not put the rate limiting just to show you guys this flow here. Sorry, let's log in again. To just show you guys the flow about the microservices, so I'm not going to put the rate limiting. Let me just show the architecture again. Okay, here we go. So just moving forward to my Postman here to show you guys the API exposed itself. So like I said, I have my basic path already configured, Hope Innovation. Dash bank, dash v1, dash account, which is my exposed API throughout my API gateway. And like I said, I do have already configured an access token and a client ID because I added the client credentials validation just to show you guys that I'm not lying. If I'm not passing the token, it's mandatory. If I remove this interceptor, of course, the flow will pass, but well, just the first concern of the security itself. The gateway itself supports every single auth2 flow following specifics about their RFCs, okay? One interesting thing here, I'm already using, and of course, I'm using a self-signed certificate here. This environment is encrypted with MTLS, and I'm just going to show you guys the configuration very quickly. So this is the environment configuration of our API platform. So in this case here, I'm going to show every single logical or physical environment that we have configured. Like I said for you guys, I already have this one configured, openinnovation.apiplatform.com, which is containing MTLS encryption on the inbound. So after I'm configured my environment, I can configure my inbound address with MTLS encryption, which is this certificate here. And this is the entire configuration that we need to make to add MTLS encryption. Of course, I need the certificates, and the gateway will manage the certificates also. Although, when you add the certificate here in the gateway, you just need to configure HTTPS, of course, MTLS, and in this case, I'm using TLS 1.2 to 1.3, and just add the certificate that I'm just configured with. The certificate name is Apidays London, which is the previous one. Sorry about that, but well, this is the entire configuration that I need to do to enable MTLS on the border, meaning that my consumers will need a certificate to consume my APIs. Okay, so about the open world, open banking, open insurance, every single of them use this type of encryption at the border.
And Filipe, if you allow me a quick comment here. So
Sure.
as Filipe has just shown, right, we have two different security concerns addressed by the platform. One, it's the overall configuration of the policies and the flows, and the other one is the communication. So we are guaranteeing that the communication channels are fully secure with MTLS, as well as the policies are applied to the API flow. So there is authentication authorization. There is even, like Filipe showed there, limitation of payload size, so to guarantee that you're not receiving something that is too big or that is, going to crash, for example. So there are several different policies that can be configured to enable security. Okay.
Also, moving forward, okay, I'm adding all those security components, although other concern is the latency and what exactly it's going to cost in terms of timing and processing. Again, this is a demo gateway, okay? So those numbers are pretty high on the demo gateway, and a production gateway will be pretty different. But even on the demonstration, we are not adding that much time in terms of what we are doing behind the scenes. So as you guys can see, our gateway have a capability to trace every single call that is happening right here. So every call will be shown at this trace API. Well, we do have this filter capability, but let's just grab a success call here to see what is happening. This is an overview about this call. So what I can see here is the status of the call, the caller, the IP of the caller, the general duration of the call, the client ID which is calling, the access token used, what is the app exactly. So we do have the capability to configure apps and plans, and then I'm going to show you guys in a couple of minutes. The owner of the token, the API itself, and the URI that I'm calling. But besides this, I have the trace, which is showing me line by line and step by step what is happening behind the scenes. So right here, we're executing the API interceptors, which is the security interceptors that I just configured in the flow in the previous step. So OAuth interceptors, token validation, SQL thread protections, XXS thread protection, payload sizing, and logging. So in a demo environment, we are adding 59 milliseconds to the call. In a normal environment, this time will be 10, 12, 9 milliseconds in the average. Okay, this is a demonstration environment. Things can be a little down. After that, I'm forwarding the request to my backend, which is exposing my microservices. And this time in here is the response. And again, demonstration. So this time is pretty high, but in a production environment, probably this time will be different. After that, I'm executing the response interceptors, which is only the log, and then we finish the API call. So again, those interceptors in the security perspective does not add latency, meaningful latency for an API call, for example.
And I think that's the main message here, just echoing what Filipe has just said, is even by adding loads of security policies, we should add some others here, of course, but securing the channel, adding policies, adding validations, the overall time added to the API call isn't something significant to say, yeah, let's try to work this around. So the main message here is that it is possible to work to expose secure APIs, secure microservices, and not add too much latency to those API calls.
Just a quick overview, of course. I just show you guys a token ready-made here. Although, again, the gateway will provide this out of the box. This is the URL of the API gateway about to generate an access token. In this case, I'm providing the client ID, client secret, to give me a valid access token to call the APIs. Although where those client ID and client secret comes from. So the platform does have the capability, two capabilities actually. One is called plans and the other one is called labs. Let's start with plans, okay? So imagine that I have multiple consumers for those APIs, multiple partners, and I will create a plan for each one of those customers that I have to consume to my APIs. And then I will tell the gateway that in a specific plan, I does have, just grab my plan here. In a specific plan, for example, my plan for API days, I will use a specific API and only this API. Bank account API. Okay, let me just edit my plan here to show you guys the API itself. Okay, so in this plan, I'm just telling the gateway that I just want to use, so the access will be only granted for the bank account API only. So this is what I'm telling here. Another cool feature that we have is the billing quota here. We do have the capability to add a quota, a specific quota monthly that will tell my customer, oh, you have only 1,000 calls per month, for example, and I have the option to block the call if this quota pass or not. So this is a cool feature that we have, again, out of the box in the gateway if you want to limit and add some limitations in a specific partner or API consumer. After defining the API itself, I does have the capability to specify a specific interceptor flow, meaning that, oh, for this partner, I need to add rate limiting, for example. You can do this by the API consumer using this feature here, adding a specific flow or a specific rule per consumer, for example. And then we are going to present the summary of the plan, and that's it. The plan is configured. After that, you can configure the app itself, which is the credentials for a specific plan. So again, if I go ahead and catch up with
while
my API.
Filipe is searching there, all of the idea of these access plans, it's basically to define the scope of the API. So, yep. And now connecting to the app like Filipe is doing, you're basically define what exactly that app is allowed to do from a security standpoint as well.
Yeah. So actually, I can add multiple plans throughout an app, although this is going to define the scope of my access tokens and my client. Right here, I have my client ID and my client secret, which is I'm using to generate an access token, which I'm using the access token to access the API. So every single configuration is pretty simple, out of the box, no code involved, and that's it. We add almost every single security step that an API needs to be productive for the external world, for example. So that's it from an API gateway perspective. Okay, so let's just jump ahead from our service mesh. First capability that the service mesh comes out of the box is not really related to security is observability. Okay, so right now I can observe what is happening throughout my cluster. So at this visualization here, and those lines will become red if some or yellow if something is running in a wrong way, if I get an error in some of the requests or a lot of the requests. So the first thing here, I can see what exactly is going on online in my gateway. Sorry, on my backend perspective. Right here, I have some different visualizations, okay? I can see on a graph, I can see on the services perspective. And actually, I can see requests per second, for example. The percentage of the requests, so on and so forth. So this is the first interesting visualization that we have in a service mesh. Another interesting capability, again, is not really related to security, but is handy, is the tracing. If something is going not as accordingly, we can see on the tracing and will give me the details about the calls itself. So for example, I know that my account service will call the payment service and will call the customer service also. So at this visualization here, I can see how much time those calls are taking and if it's everything okay. So for example, if the latency of my API is start to increase, I can clearly see on the tracing perspective what service to blame and what is where is the problem exactly. So for example, imagine that the payment service have a bottleneck or something. So this time here will be significantly increasing, and well, I can see clearly that my payment service have a problem and I can go ahead and fix it.
Filipe, just before you proceed, there is a question here from Vishy. Vishy, you asked if there is any performance metrics, particularly for the north and south traffic, with all of these security policies in place. When it comes to metrics, to the collection of metrics in the API gateway, Each corporation will have specific metrics, but when it comes to showing those, we can easily identify by the creation of dashboards, and of course, not only the trace that Filipe showed, that you can understand exactly what is going on, but you can identify some specific metrics if that's needed.
We do have here an embedded Kibana on our API gateway, which is, we have two major indexes, and the first index is the metrics one. So at this visualization here, you can see the metrics of the entire platform itself. And of course, it's free like Kibana, it's a Kibana. So we can create visualizations, we can create custom graphics. This is the default one that we are just showing the percentage of the status code that we are having. Latency, average latency, request count. Of course, those visualizations are not too fancy here because this is a demo environment and does not have huge traffic here. Top-end APIs, and well, feel free to create whatever visualization that you guys want. So this is the capability, one of the capabilities that the gateway have. So we does have metrics, and we can, talking about security itself, we can add custom dashboards here to address some use cases.
Yeah. Thank you, Filipe. And Vichy, if that doesn't answer your question, feel free to send another message there, and we'll address it.
Moving throughout our service mesh again. So the service mesh here is, of course, we do have a Kubernetes cluster behind the scenes here. And this Kubernetes cluster have those namespaces here, okay? The namespace about that we are using to produce our demo is the Sensedia Bank one. So right now here at this visualization, I can see if those namespaces are being managed by our service mesh. The Sensedia Bank is being managed by our service mesh, of course. It is healthy, meaning that every pod is okay inside of it. We does have 7 pods up and running at this namespace. And the first interesting configuration here. So to add MTLS encryption in the ingress gateway, and using this MTLS encryption. So the only configuration needed is to provide the secret, which is configured within Kubernetes to not be exposed throughout our service mesh. I do have a secret configured with the MTLS certificate, which is self-signed, of course. Name it flow credentials, which is a YAML that I've just applied on my Kubernetes. And here, I just have my host, which is an Amazon load balancer. This is just a configuration detail. But with this configuration, I mean that my namespace, meaning all my north and south flow that's come inside my cluster, will have MTLS encryption, and we'll use the certificate configured throughout Kubernetes. And that's it. This is the only configuration that I need. So just to show you guys the configuration running here, will be a little bit ugly, but it's one of the only ways to show you guys that the thing is actually up and running. This is the load balancing here, and I do have in my Postman my certificates here, which is the same certificate from my load balancing perspective. Okay. So, like I said, the communication between our backend, which is Kubernetes Service Mesh, within our API gateway, will use MTLS encryption. So this is the only configuration that I need. And of course, I need to configure the certificate in my API gateway to be able to consume those services. Enter in the cluster, in the namespace itself, I can see the services perspective and the amount of pods for each service, okay? This is just a test that we are scaling to 0 pods here using a new technology, but this is not involved on the demo. in our services, in our demonstration, it does have 1 pod for account, 2 for customers, and 4 pods for payment services. Entering the accounting service here, I can see interesting information also, which is the name of the pod, if it's healthy or not. The source here is where the traffic comes from, who is calling this service. Some tailor-made metrics. So request volume, duration, response size, and request size, which is pretty average here because just myself is calling this API today. And the interesting part, traffic management, which is where we are going to configure internal and external flows. At this point, I just have 2 deployments itself because traffic management here, translating to the Kubernetes perspective, are deployments itself. I have one external deployment, meaning that I will be able to call Dash accounts externally, meaning that every external flow will go through my V1 container version, okay? And this link here will toggle the API, which is publicly exposed in my API gateway, which is the same link, providing part of the integration between the service mesh and the API platform. And this tag here, meaning that this configuration, specifically this deployment, will use MTLS encryption, and the MTLS encryption will use the certificate that I just showed you guys in the previous step. This is the external configuration, meaning that I'm being able to call it from my API gateway perspective. And I do have another capability to provide an internal deployment, which is service-to-service communication. I just have this account service be available in internal fashion. This is what is going to look like. And again, if I want to add MTLS encryption, even in the east-west communication inside my cluster, just enable the MTLS encryption, and the service will use this encryption with the same certificate that I just showed you guys to communicate within service to service. And this will flow throughout the other services, but I just going to show a nuance here. Right here for the payments, just ignore these external guys just for testing. Let's focus on the internal perspective here. I just have 2 internal deployments, one general, which is payments stable, just like the account one, and I'm using MTLS. But the other one is more interesting, which is I'm using a canary release here, meaning that 30% of my flow, of my entire flow, for the payment service internally will be directed to my V2 container version. So, and I'm not using MTLS at this point, but I can enable it. Meaning that this is the entire configuration needed, and we are abstracting how we are doing canary releases. And we do have 2 options here to build canary releases: by weight, which is here 30% of the entire traffic, or by header, meaning that imagine a family and friends deployment, meaning that I will have a specific header showing me that I need to redirect this flow to a different version to test, for example. It's simple as that. I provide what is the header and what will be the value of the header, and this will be redirected to a specific container version behind the scenes. And just to show you guys, just change visualizations here, the version graph. As you guys can see, of course, it's near real time. It's not exactly real time, but the payment service here down there, approximately 30% of the traffic will be redirected to the V2 container version. And as more requests come through, more proximal to 30% this number will be. Actually, and the last thing from our service mesh perspective, We do have the capability to provide authentication and authorization. I'm not going to configure this live because I'm going to kill every other service because it's not proper configured here, but those configurations are using OpenID perspective, so feel free to use any OpenID provider. Just provide the name, the port of the service itself, and we can exclude or include specific path to add an authentication perspective or an authorization perspective. And the authorization perspective, of course, we will have the key and value perspective on what we are looking for in the token itself to authorize somebody to use the service. And again, those configurations being made out of the box, no configure involved, meaning that the development team will focus only on what really matters, which is code the business itself. Security, traffic management, and other nuances will be held in the platform itself, the Sensedia platform. So I think that's it for demo. We do have any questions, other questions, Gibson?
Yeah, there's another one from Ankush. Sorry if I'm not spelling your name correctly. Regex based on XSS protection provided by Gateway is very basic and could create problems. Do you think that using WAF would be more appropriate in protecting the API against injections?
Yes, we do have some integrations for public web application firewalls. So if you guys are using public-facing APIs only, meaning that your APIs will be called directly to mobile apps and so on and so forth. So the solution now, WAF perspective will be way better. Yes, you're right.
Yeah, so we have only 3 more minutes left. If there is any other question that we can answer in these 3 minutes. Otherwise, I'll be wrapping up very quickly here. I'm not going to bother sharing my screen again because there's just the thank you slide. If you want to connect with us, send us any message on LinkedIn or even here using the Hopping platform. Feel free to do so. We'll be more than happy to either have a chat, call, or just discuss about any topics you may have. Otherwise, I'd like to thank you all for joining our session. Hopefully it was, of good use of your time. And again, thanks API Day for the opportunity to present this workshop. Thank you very much.